So you subtract the F1 from our FR, which is the resultant. So we have F2 bar equal to FR, which is 0I plus 800 J plus 0K minus the whole of F1 bar, which is 212.132I plus 150J minus 150K. Please, I hope you are with me. Very good. Now we are going to do this subtraction. So F2 bar will be equal to minus 212.132I because we subtract I from I. Yes, and J from J plus 800 minus 150, which is giving us 650 J. Then we have 0 minus 150, which is giving us positive 150 K. So this one is the F2 in a Cartesian vector form. But we want the F2 in a magnitude form, in a scalar form. So we have our F2 to be equal to root of. So if you have it in a Cartesian vector form, you want to find it in to get the magnitude form. To get the magnitude form, you just have to find the square root of the square of each of the components. So you take minus 212.132, then you square it neatly, plus 650 squared plus 150 squared. Like we are finding the magnitude of a vector. So F2 will be equal to 699.96 Newton, which is approximately equal to 700 Newton. So this gives us our F2. That's the magnitude of the F2. I hope you are with me. Very good. Now, let's move on to the other part of the question, which says we should find the what? The directional cosines, the coordinate direction of F2. That's we want to find theta x for the F2, theta y for the F2, and theta z for the F2. Very good. Now I want to do something here. So if you represent the F2 in a Cartesian vector form, this is what we are having. So the actual formula for F2 without the figures, you have F2 bar will be equal to F2 cos theta xi plus F2 cos theta yj plus F2 cos theta zk. Very good. So this F2 bar, this F2 bar. So we are going to compare the coefficients. So over here we have the coefficient for the I to be negative 212.132. So equating that to this, we will get F2 cos theta x. Very good. But already we know our F2 to be what? 700 Newton. So we put the F2 here. Now we'll get cos theta x equal to negative 212.132 divided by our F2, which is what? 700. So theta x will be equal to cos inverse of negative 212.132 divided by 700. And our theta x will be given to us, or we will get our theta x to be 108 degrees. 108 degrees. So let's proceed to solve for the other angles. So we have our theta y and our theta z to also calculate 4. So we are still going to compare. We are still going to compare those two equations. We are going to compare the two equations. So comparing the two equations, we will again compare the coefficient of j here to the coefficient of j here. So get f2 cos theta y equal to the coefficient of j, which is 650. So we get our f2, which is 700 cos theta y, to be equal to 650. So you divide here by 700, this side 2 by 700. This takes off this. Cos theta y will be equal to what? 650 over 700. So theta y will be equal to cos inverse of 650 over 700. Theta y will thereby be equal to 21.79 degrees. 21.79 degrees. So let's solve for our theta z. So comparing again, we'll get 700 cos theta z, which will be equal to 150. So cos theta z will be equal to 150 divided by 700. Divided by 700. Theta z will be equal to cos inverse of 150 over 700. And our theta z will be given to be, our theta z will be equal to 77.6 degrees. So therefore, our magnitude for the F2 is 700 Newton. Our theta x, that's the directional cosine for F2 with respect to the x-axis, which is theta x, is 108 degrees. Our theta y is 21.79 degrees, and our theta z is 77.6 degrees. Thank you once again for joining us to go through this particular question, and hope to see you in our next video.